So guys, in the last class we stopped from this question where the position of a particle is changing with respect to time as h is equal to t cube upon 3 up minus 3t square upon 2 plus 2t plus 4, where x is in meters and t in seconds. X in meter, t in seconds. So there are five sub questions here. The first is we have to find its initial position. Initial position. So initial position is we have to substitute t is equal to 0 because that will be its initial position. So x is equal to 0, plus 0 cube is 0, minus 0 plus 0 plus 4. So the initial position comes out to be 4 meters. And the next question, the B sub question is we have to find its velocity and acceleration. So velocity will be differentiation of position with respect to time. Velocity will be differentiation of position with respect to time, which will be differentiation of t cube upon 3 minus 3t square upon 2 plus 2t plus 4 upon t. So this will be 3 comes here, so it gets cancelled with the denominator. So this becomes t square minus this one 6. So 2 gets cancelled with 6. So this one 3t t square minus 3t plus 2 plus 2. Yeah, t square minus 3t plus 2. This is our velocity. And also we have to find acceleration. Acceleration will be dv upon dt. So this will be differentiation of t square minus 3t plus 2 upon dt. So this will be 2t minus 3. So the third sub-question, the C sub-question, is we have to find the time when the particle is taking turn. So in 1D motion, as there is only one axis which is x, the particle cannot take turn like from here to here or here to here or here to here or here. It has to take turn like this or this. So if you take turn, your velocity will become zero. So we have to find when the particle is taking turn. When particle is taking turn, velocity becomes zero. So we found the velocity function which was velocity is equal to t square minus 3t plus 2. We have to equate this equation to zero because we have to find when will it be zero. So when is time, when we have to find its time when it will be zero. So this is a quadratic equation. So we have to find 2 when added it will become 3. So 2 multiplied by 1 will give you 2, but after addition this will give you 3. So add the variable, variable 3. So this one, yep, t square minus 2t plus t plus 2 is equal to 0. So this one t square minus 2t minus t plus 2 is equal to 0. So t comes out common, t minus 2, and here the minus comes out, minus 1 comes out. Okay. T minus 2 is equal to 0. So this becomes t minus 2 into t minus 1. 0 is here. So t comes out to be 2 or 2 and t is equal to 1. So at t is equal to 2 and at t is equal to 1 second, this particle is taking turn. So we have an idea of the motion of the particle. Initially, it was at rest because we found the initial position. It was at 4 meters. Then it started at, at t is equal to 0. Okay? So at t is equal to 1, it took a turn. And at t is equal to 2, it took again a turn. So this becomes like this. And it keeps on going. So now the D part of the question is with D part of the question. We have to find its position and velocity when acceleration is zero. So we found the acceleration as the function of acceleration as 2t minus 3. So the time will be when the acceleration is zero. So equate it with zero. Accelerate time will be 3 upon 2. 3 comes here and 2 goes to denominator. We have to find its velocity. So velocity will be, we got the time. So just substitute 3 by 2 in place of t. So this becomes, what was the function of time with velocity? T square minus 3t plus 2. So this becomes uh, c by 2 square minus 3 into c by 2 plus 2 meter per second. We can solve this. So this becomes 9 by 4 minus 6 by 2 plus 2. Multiply this by 2 and this by 4. That's 9 by 4 minus 12 by 4 plus 8 by 4. This will be 9 minus 12 plus 8 upon 4. So 9 to minus 12 plus 9 becomes minus 3. Minus 3 plus 8 becomes 5. 5 upon 4 becomes 5 upon 4 meter per second. And the this was the D part. So E part of the question is find the time interval when the particle is accelerating or retarding. So let me explain first the acceleration and retardation. So whenever the velocity and the particle, the sign of them or the direction of them is same, the particle is accelerating. Or when it supposes the particle is retarding, like if velocity is greater than zero, acceleration is also greater than zero, then the particle is accelerating. And if the velocity is less than zero and acceleration is also less than zero, still the particle is accelerating because the the direction and direction and the sign is same for both of them. But if the velocity is positive or greater than zero, but acceleration is negative, then the particle is retarded. And if the velocity is uh, less than zero, but the acceleration is greater than zero, so it's positive and velocity is negative, so this again is retarded. So when the velocity and acceleration are equal, that it is accelerating. An important point, negative acceleration does not mean retardation. Negative acceleration does not mean retardation. So let's solve one question. Find the time interval when the particle is taking turn. Find the time interval when the particle is accelerating or retarding. So we have velocity as we have three time intervals. When we found out the particle is taking turn, so the velocity will be zero, and when the acceleration will be zero. So velocity is equal to t minus 1 and t minus 2, and acceleration is equal to 2 into. So here we have to draw a number line 1, 2, 3 by 2, and 3 by 2. Yeah, this is right. So if t is less than 1, if t is less than 1, then this will be negative, this also will be negative, so this becomes positive. Velocity will be positive from if it's less than 1, so this will be here, right? 0, 1, 3 by 2. So if the velocity is less than 1, so the velocity, when the time is less than 1, velocity will be greater. And if it's between 3 by 2 and 2, we are not talking about velocity, so let's take from 1 and 2. Between 1 and 2. So this will be negative, this will be positive. So this becomes negative. But we less than 0, velocity will be less than 0. Here if more than greater than 2, then this also will be positive, this also will be positive. So this also positive, this also positive, this becomes positive. Now let's talk about acceleration. So when time is less than 3 by 2, when the time is less than 3 by 2, so this will be negative. Less than 3 by 2, it will be negative. Acceleration less than v. If it's greater than 3 by 2, then it will be positive. Acceleration greater than 0. So now figure out where its velocity and acceleration are same. Where it's different from 0 to 1. But from 1 to 3 by 2, you can see it's same. It's greater than 0. Therefore, from 1 to 3 by 2, 1 to 3 by 2, acceleration. Again, opposite. But here you can see it's the same. Therefore, from here, from beyond 2, beyond 2, again acceleration. But from 0 to 1, retardation. And from 3 by 2 to 2, um, it's again retardation. Now let's check the F part. So we figure out where it is retarding or where it's accelerating. One more point where whenever the velocity is zero in 1D motion, the and only motion negative velocity is equal to motion in negative x-axis. Motion in negative x-axis. Now let's check the F part of the question. Find the total displacement of the particle between t is equal to 0 to t is equal to 3. So displacement is nothing but final position minus initial position because it's the shortest distance with shortest path. So displacement is x final minus x initial. So x final is nothing but position when t is equal to 3 and x initial is nothing but position when x is equal to t is equal to 1. Here the initial position we have to take 0, sorry, not 1. In the question it has said we have to take initial position as 0. So x initial is equal to x when t is equal to 0 and x final is equal to x when t is equal to 3. So this the x final will be, we know x initial will be 4 because we have our equation. Let me write it again. T cube upon 3 minus 3t square upon 2 plus 2t plus 4. This was the equation, right? T cube upon 3 minus 3t square upon 2 plus 2t. So yeah, this is right. So we have to substitute t3 if we have to find x final. So this becomes t on this becomes t square minus 6 ct minus 2. We have done this question. Yes. Now we don't have to differentiate, we have to find its position, not velocity. So position will be, let us just substitute 3 here. 3 cubits will be 27. 27 by 3 minus. So I will write 9 here because it's divisible by 3. 9 minus. It's 9. 9 27 by 2 plus 6 plus 4. So this will be 18 plus 20, 18 minus 27. 18 minus 27 plus 12 plus 8 upon 2. Let's solve this. I have to take some help here because I can't waste time. 18 minus 27 plus 12 plus 8. So this becomes 11 by 2. This becomes 11 by 2 meters. And in our initial position, so let's substitute 11 by 2 in place of final position minus 4 in place of initial position. So this becomes 11 by 2 minus 8 by 2. This becomes 3 by 2, right? Meters. Let's write it as 1.5 meter. So now the last, the G part of the question, not the last part, the G part of the question, we have to find its distance. So distance is nothing but the total path when the time was 1 second and 2 seconds. So position when the time was t is equal to 1 second, position when the time was 2 seconds, position when the time was We have to find all of this. This is super time taking, so I will not write this. We just have to substitute one in place of t in the equation, then two in place of equation and three, and then add the whole thing, not sub subtract, because we are not finding displacement, we are finding distance. In distance, if you walk around the circle, if you start from here and you go from here and come here, the displacement will turn into zero, but the distance will add up. If you go again, it will add up. So this is an easy question. I will solve this. Uh, we have to find and the average velocity and average speed in the last question. So average velocity is nothing but total displacement upon time. Our displacement was 3 by 2, right? It was 1.5. 1.5, yes. 3 by 2, 1.5 upon 3. Because total time is 3. So this is a 1 upon 2. And 1 by 2 meter per second. We also have to find average speed. Average speed is total distance upon time. And distance will come out to be, if we solve that question, so it will come out to be 11 by 6 and divide by total time, which is 3. So this was 11 by 6 into 3. This was 11 by 18 meter per second. So this was a question and answer. Now we start the question which we skipped or we didn't complete in the last class. So now let's start a new topic which is differentiation by substitution. Def by substitution. Let's take one example like y is equal to sine x square. In a traditional way, we will solve this as sine x as cos x, but this is not sine x, this is sine x square. So we can't solve like sine cos of x. We have to substitute, as the name says, substitution. We have to substitute something. This x square is our problem. If this was sine x, we would have solved like cos x. So let's substitute t as x square. So y becomes sine of t. Now this is easy. So y dot. Now this dot will represent dissociate. I will not add this. You will get confused. Dy by dt. This is not dy by dx. This is dy by dt because this is function of time. This will be cos t. But we have to find dy by dx because initially this was function of x. Where is x? This is dy by dt. So for finding dy by dt, I will write this one. Dy by dx is equal to dy by dt, which we have. Which we have. We have to multiply it by something to get dy by dx. If we take dt in the numerator, we will find the dy by dx. So dt by dx, we will find dy by dx. But we have the time as a function of position here. Time is equal to x square, the position square. So dt by dx is equal to 2x. Differentiating time with respect to x. This one to x. We have this dy by dt here, and we also got dy by dx. dy by dt by dx is 2x. So dy by dx is equal to cos 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 t multiplied by t by dx, which is 2x. So, but we can't keep t like this. We have to resubstitute t as x square. So dy by dx becomes cos x square into 2x. This is our answer. As this was not sin x but sin x square, we had to do such complex thing. But this is not complex to be honest, but still we have to take a long part to get this answer. Next question, example 2. Find dy by dx if y is equal to sin square x. If y is equal to sin square x, we have to find dy by dx. So write y as sin x the whole square. This means the same thing. So this is not sin x. We had x to the power. We never had sin x to the power 2 or 3. So substitute sin x as t. T is equal to sin x. T to sin x. So y becomes t square. So dy by dt becomes 2t. But we want dy by dx. Dy by dx will be 2t, which is dy by dt multiplied by dt by dx. This differentiation will be dt by dx will be cos x multiplied by cos x. But we substitute t as sin x because we can't keep t as t. We have to resubstitute 2 into sin x multiplied by cos x. Therefore, dy by dx is equal to 2 sin cos x. This is our answer. Third question. If y is equal to if y is equal to sine of 4x, find dy by dx. Here we don't have sine x, we have sine of 4x. So substitute 4x as x or t. So 4 t, t is equal to 4x. So y becomes sine of t. 4x is t. So by dy by dx becomes cos t. But we want dy by dt becomes. So dy by dx will be cos t multiplied by dt by dx. Be 4 multiplied by 4. We substitute cos of 4x into 4. Therefore, dy by dx is cos of 4x into 4. One more question. The question is find dy by dx if y is equal to if y is equal to under root of sin x. So wait a second. We can also write this as sin x to the power half. So y is equal to sin x. Now substitute sin x as t or x because we never had any power to sin x. We had it to x or t or any variable. Never had to any trigonometric ratio. Not a trigonometric ratio, but sin x. We never added to sin x. So t is equal to sin x. Therefore, y becomes e raised to power r. So dy by dt becomes half t 1 by 2 minus 1 is minus 1 by 2. So we have to find dy by dx, not dy by dt. So this becomes half t minus 1 upon 2 multiplied by differentiation of this dt. I will not write the cos x multiplied by cos x. So this becomes p raised to minus half. So this will be under root but in denominator too. So this one cos x upon 2 root t, but t is sin x. So let's try to find our answer. Dy by dx is equal to cos x upon 2 under root sin x. Now this is enough. We can't solve like this long way, such long way. So let's find some easy way. Like the first question which we had, y is equal to sin x square. The answer of this was cos x square multiplied by 2x. Now figure out how was this answer cos x square multiplied by 2x. We multiplied the first term, then the second term. Look, if we multiply, if we differentiate this whole thing, we will get this. Now don't look at sin x square as sin x square. Look at this whole thing as x. So this will become uh, this look at this as cos x. Just copy the whole thing, but differentiate the first term. This becomes cos x square multiplied by the second term. This differentiation of this will be 2x. So the answer was this. Now let's take a second example. Y is equal to cos x cubed. What will be the answer of this? So y dot for dy by dx will be differentiation of this cube. This becomes sine minus sine minus sine x cube. After writing the differentiating the first term, after differentiating the first term, just copy the thing which was uh, um, in front of it. Don't differentiate it. We will differentiate two times. Multiply by differentiation of this, which is 3x square. So our answer is this. Look how easily we found the answer. No many long steps. So one more question. If y is equal to sine x squared. Hmm. So first, treat this thing as x first. So this becomes y dot our differentiation of y with respect to x will be 2 sin x. Because if we have x squared, so this becomes, look at this thing as x squared. This whole thing as x squared. X. So this was x squared. So the differentiation of this was 2x. So we got 2x. 2 sin x. This was x. Multiplied by differentiation of the next term, which will be x raised to 2, which will be 2x. But the answer is 2 sin x multiplied by cos x. So, yeah, we this wasn't the first term. We took this as x, so the next term will be sin x. Yeah, so the answer will be 2 sin of cos x. Fourth question, y is equal to ln sin x. So y dot will be, if there is ln function, we write the function in front of it in denominator. So 1 upon sin x multiplied by cos x. Because we have to differentiate first this, then this. So our answer is this. And write this as cos x upon sin x, which is cot x. You can keep this like this, or you can just simplify it to get this. One more question. Sixth question. Y is equal to ln sin 2x. So first we have to differentiate with this, then this, then this. So this becomes 1 upon sine of 2x multiplied by cos of 2x multiplied by 2. This is our answer. We got the answer because there are three terms. We had to, if there are three terms, we will have to substitute two times. We just saved ourselves from long steps. One more question is phi is equal to under root of sin x, then find dy by dx. So y will be, let me simplify this, y is equal to sin x to the power half. So treat this as x first because we never have power to sin function. We have sin x to the power minus 1 upon 2, and after we suppose this thing as x, we have to differentiate the thing inside of it, which is sin x multiplied by, so the differentiation of sin x is cos x. So answer is dy by dx is equal to this. One more question. If y is equal to 4x plus 5 raised to power 99, we have to find dy by dx. This one looks tough, but this is easy. We have to first suppose this thing as x. So if you suppose this thing as x, so what will be answer? 99x to the power 98. So write this thing like 99. Our x is 4x plus 5 raised to the power 98 multiplied by the differentiation of thing inside of it. The differentiation of this thing will be 4x plus 5. This is a constant, so this will become 0. The differentiation of 4x is 4 multiplied by 4. This is the answer. dy by dx is equal to 99 into 4x plus 5 raised to power 98 multiplied by 4. Uh, One more question. Y is equal to ln tan under root x. So first we have to differentiate this, then this, then this. So dy by dx will be 1 upon tan under root x multiplied by tan, the differentiation of tan x. Suppose this thing as x. So tan is sec square x, right? Sec square under root x. This will be sec square under root x multiplied by differentiation of this. So this becomes under root x is equal to x to the power half, which will be 1 upon 2 x minus 1 upon 2. It becomes x raised 1 onto x raised to power minus 1 upon 2. This is our answer. Let me see if we can simplify. So sec square under root x into now upon tan under root x multiplied by 2. This is in negative, so this should come down and this is half, so this will come in under root multiplied by under root of x. So this is a simplified version. dr by dx is equal to this. One more question. If y is equal to 4 tan theta, then 4 tan theta minus 10 by 2 minus 10 by 2 cos square theta find dy by d theta. So this will cancel out by 5. So this and 1 upon cos square theta will be 1 upon cos is sec. So 1 upon cos square theta will be sec square theta. So let me simplify y. Y is equal to 4 tan theta minus 5 sec square theta. Now we have to differentiate this one, and after that this dy by d is equal to 4. The differentiation of tan theta is sec square theta. And you can see this is simple tan theta. There are no powers or anything. So this we will simply write this as sec square theta. 4 multiplied by sec square theta minus 5 into. As the 4 is in multiplication with a function, it will remain as it is. If it was alone, it will become 0. So 5 multiplied by sec square theta. We don't have sec theta, we have sec square theta. So we have to, I will write, simplify this thing here. Sec theta, this will be sec theta raised to power 2. So this will be 2 sec theta uh, raised to power 1. This will be 2 into sec theta. And the differentiation of sec theta is sec theta tan theta. So this will be multiplied by 2 into sec theta tan theta. So our answer is 4 sec square theta minus 10 sec theta tan theta divided by theta. This is our answer. One more question. The question says that the position of a particle in linear motion varies with time as x is equal to the position of a particle in linear motion varies with time as x is equal to a sine theta, a sine omega t plus phi. This sine is omega, this is phi. So and a and omega and Phi are constants. So we have to find velocity and acceleration. Velocity and acceleration, we have to find this. So velocity will be dx upon dt. So this will be differentiation of this a sine omega t plus phi upon dt. As a is in function with a is in multiplication with a function which will remain as it is. A multiplied by sine of this thing will become cos of differentiate this, then this, then this. This is our rule. So the way we solve this, first differentiate this, then this. Now the differentiation of this thing will be as phi and omega constants. Phi will get eliminated because it is a constant, so it will become zero after differentiation. This is a constant with a function with power 1, so this will become omega. Therefore, velocity is a omega cos omega t plus phi. We also have to find acceleration. Acceleration will be dv upon dt. We have our velocity function. We have our velocity function as differentiation of a omega multiplied by cos omega t plus phi upon dt. First differentiation of this is multiplication sign I'm cancelling because you will get confused. So as a omega is in multiplication with the function, this will remain as it is. If a constant is in multiplication with a function, it will remain as it is. A omega into this will become minus sine theta. The differentiation of cos theta is minus sine theta. Cos x of cos theta minus omega t plus phi. Now we differentiated this, we also have to differentiate this. So differentiation of this will be divided by this is a constant and this is a constant. So this will get eliminated. We are left with omega. The answer is a omega square. The omega square because this and this omega get multiplied. Minus comes out. The minus comes out. A minus a omega square sine omega t plus phi. So dv upon dt or simply acceleration. Acceleration is a omega square sine omega t plus phi. Now let's stop here. We are done with two lectures on differentiation. The next lecture will be a short lecture on differentiation. It will complete our chapter of differentiation. Then I will start integration. So bye.